Okay, so just take a second and think about how much of your day really depends on databases.
Hmm.
I mean, checking your bank account, streaming a movie, booking a flight. It's all databases, right?
Oh,
Behind the scenes.
it really is. It's kind of the hidden plumbing of the digital world. And at the heart of so much of it is this idea, the, the relational database.
Exactly. And have you ever wondered, like, where did that actually come from? What was the spark?
Well, that really brings us to Edgar F. A British mathematician, a computer scientist. One source we looked at called him a visionary who redefined data itself. Quite a statement.
It really is. And if you're listening and you want to get a handle on these crucial technologies, without wading through dense textbooks, this deep dive is definitely for you.
Yeah, we're aiming to unpack what really drove COD to this breakthrough, this relational model, and crucially, the impact it's had, which is just immense.
Right. We looked at his original paper, some biographical stuff, the whole tech scene back then, trying to piece together the whole story.
So let's set the scene a bit. Before COD, what did data management even look like?
Well, the descriptions we found were things like clunky. Data was often locked in rigid hierarchies.
Yeah, imagine like a really strict, old-fashioned filing cabinet system. You had to know the exact path to get the information you wanted. No detours allowed.
Super inflexible.
Totally. These older models, the hierarchical and network ones, were often called tedious, error-prone, and inaccessible to most users. Really, they were built for engineers, not for, regular people needing answers from the data.
You can almost feel the frustration building, can't you? Which leads us to Cod's big question, the game changer.
He essentially asked, what if we could manage data using logic instead of navigation?
Logic instead of just following preset paths. Simple question, but wow, the implications.
Huge. And that question got his big answer in 1970. He published this paper, A Relational Model of Data for Large Shared Data Banks. It was in the Communications of the ACM.
And that paper wasn't just another paper, was it?
Oh no. It's widely seen as, and I quote, one of the most important documents in computing history. It really laid out a whole new blueprint.
Okay, so let's dig into that blueprint. What was the core idea? What made it relational?
Right, so the basic idea was deceptively simple. Store data in tables, just straightforward tables, which COD called relations.
Okay, tables, we get that.
Okay,
But what was the revolutionary part?
the revolution was how you worked with those tables. He proposed using ideas from set theory and mathematical logic. So instead of needing to know the physical path, you could combine data, query it, manipulate it based on logical conditions. What's in the data, not where it's stored.
Ah, so separating the what from the where, moving away from those rigid, often proprietary systems.
Exactly. Towards something more universal, more logical, like swapping a maze for a well-drawn map, maybe.
I like that analogy. So these tables, these relations, they weren't just random lists, I assume. Cod built in some structure.
Oh, absolutely. Critical concepts. He introduced normalization. Think of it as a set of guidelines for designing your tables to cut down on repeated information redundancy and make sure the data stays consistent, data integrity.
Right, avoiding errors and repetition makes sense.
Then you have keys. These are like unique ID numbers for each row in a table, and they're crucial for linking related data across different tables.
The connections between the tables.
Precisely. And he also formalized relational algebra, a kind of mathematical language for precisely asking questions of your data, manipulating these tables, and maybe most importantly, data independence.
Data independence, what's that?
It means you could change how the data was stored underneath the physical structure without necessarily breaking all the programs or applications that use that data. The logical view stays separate from the physical storage.
Okay, that sounds like a huge advantage, flexibility.
A massive leap forward, yeah. It makes systems much easier to maintain and evolve.
And all this logical foundation, this is what eventually led to SQL, right? The language most databases use today.
Exactly. COD's model, his relational algebra and calculus ideas, they provided the theoretical bedrock, the blueprint for what became SQL, structured query language.
It's kind of the lingua franca of databases now.
Pretty much, yeah. The standard way to talk to most relational systems.
But, great ideas don't always get instant acceptance. I gather Cod hit some roadblocks, even at IBM where he worked.
Oh, definitely. That's a key part of the story. IBM had poured a lot of resources into their existing database tech, particularly IMSDB, which was hierarchical.
So they had a vested interest in the old way.
They absolutely did. There was a real fear that COD's model would, well, cannibalize their successful products, make them obsolete. So as one source noted, IBM was initially slow to exploit his suggestions until commercial rivals started implementing them. Competition often forces hands, doesn't it?
It certainly does. So others started seeing the potential even if IBM was hesitant.
Yes, and Codd himself was proactive. He apparently made a point to show IBM customers the potential of the relational approach.
Going directly to the users. Smart.
And it worked. Those customers started seeing the benefits, the flexibility, the logic, and put pressure back on IBM.
So IBM eventually had to respond.
They did. They started a project, or rather a sub-project called System R.
Okay, System R. Was that Codd's baby then?
Well, not quite. This is where it gets a bit complicated. The team put in charge of System R. Let's just say they weren't entirely on the same page as Codd. They developed their own language, SQL, which evolved into SQL.
So not Codd's own preferred language, Alpha.
Correct. SQL drew heavily from his relational ideas, absolutely.
Right.
But it wasn't a direct implementation of everything Codd envisioned. But here's the kicker.
Yeah.
Even this adaptation, SQL, was, and again I'm quoting, so superior to pre-relational systems that it made waves.
How so?
Well, a certain Larry Ellison saw its potential, adapted it, and released it as Oracle database. And Oracle actually beat IBM's own SQL product, SQL DS, to market.
Wow. So the power of the core relational idea shone through, even in someone else's implementation.
It really did. And Codd, meanwhile, he didn't stop. He kept refining the model, working with others like Christopher J. Date. That collaboration led to things like Boyce-Codd normal form, and even stricter level of normalization.
Pushing the theory further.
And proving things mathematically, like Codd's theorem, which showed that his relational algebra and relational calculus were equally powerful ways to query the data, just solidifying the foundations.
He seems like someone really dedicated to the purity of the idea.
Extremely, which actually led to another chapter later on. As relational became a buzzword in the 80s, Codd got worried vendors were just slapping the label on old tech.
Marketing hype.
Right. So he published his famous 12 rules, a checklist, basically defining what a truly relational database system had to do.
Setting the standard. Did that go down well?
It certainly clarified things, but his, let's say, uncompromising stance on adhering to the model reportedly caused some friction back at IBM. Eventually, he left to start his own consulting firm with Chris Date and others.
A purist sticking to his guns. So, okay, we've seen the idea, the resistance, the eventual adoption. Let's talk about the impact, because it feels monumental.
Monumental is absolutely the right word. Think about it. Almost every major technology owes something to the relational database model. That's a direct quote, and it's hard to argue with.
Give us some examples. Where do we see this legacy?
Everywhere. Hospitals managing patient records, airlines handling flight bookings and schedules, complex logistics, financial systems, inventory management. The list just goes on and on.
Anything that needs structured data.
Pretty much. Okay. And all the modern RDBMSs, PostgreSQL, SQL Server, MySQL, Oracle, DB2, they all fundamentally stem from Codd's logic.
And those 12 rules you mentioned, still relevant.
They definitely are. They serve as a kind of touchstone, a benchmark for understanding what relational really means. Even now, with newer database types emerging.
Like NoSQL and things like that.
Exactly. And cloud data warehouses like Snowflake. While they address different needs, maybe scaling differently or handling unstructured data, you can still see the influence of Codd's original push for flexible, logical, and efficient data access. Many are reactions to or evolutions from the relational model.
His ideas cast a very long shadow, and he got recognition for this, right? Awards?
Oh, yes. The big one was the ACM Turing Award in 1981 that's often called the Nobel Prize of Computing. The citation specifically mentioned his fundamental and continuing contributions to the theory and practice of database management systems.
That's huge.
Definitely. He was also made a fellow of the ACM. And later, Sigmod, the main academic group for data management, renamed their top prize the Sigmod Edgar F. Codd Innovations Award.
A fitting tribute. There's a quote from Codd himself that seems to sum it up well.
Which one are you thinking of?
The power of the relational model is not in what it does, but in how universally it can be applied.
Ah, yes. That captures it perfectly. It wasn't just a solution. It was a fundamental, widely applicable way of thinking about data. And even though he passed away back in 2003, well, as we've been saying, the system he imagined lives on.
Absolutely. So wrapping this up, it's clear Codd's relational model wasn't just, a technical tweak. It was a revolution in thought.
A complete paradigm shift.
Yeah, overcoming that initial resistance, it eventually just became the foundation for so much of our modern tech. It really feels like he didn't just invent a better way to store data, he gave us a new way to understand it.
That's a great way to put it. This whole journey, from his initial frustration with clunky systems to this incredibly pervasive global impact,
Yeah.
it really highlights how one really powerful logical idea can reshape everything.
It really does, and it
Mm.
leaves you thinking, doesn't it? Just try to imagine the digital world without the structure and the accessibility the relational model brought. What might we not have? What innovations would have been stalled or maybe never happened at all?
It's a fascinating thought experiment.
Something definitely to chew on next time you check your bank balance online or book a flight.